I'm Danielle. Thank you so much for coming out today. I'm from honeycomb.io, and we're going to talk today about SLOs, or service level objectives. Now, I strongly believe every good talk should start off with the disaster, so then it's just, uphill, so then it's just an improvement from there. So I'm going to tell you about an outage that we had at Honeycomb. This is, July 3rd, July 9th of this year. And this is looking at one of the Honeycomb data graphs as our, data processed along, and something happened about 3 o'clock. I would love to say it's that every one of our users simultaneously went out on a coffee break. I would love to tell you that it's because the internet simply became profoundly uninteresting for that minute, but that unfortunately is not true. If I zoom in a little bit further, we can see a little more of the truth, that around 3:50, some of our servers started collapsing and something was going away. By 3:55, everything was down, and it stayed that way for 10 minutes. The question that I'm posing by putting these few starting slides up is the question of how broken is too broken. I mean, that was bad, I think. It was 10 minutes. I like to figure out this sort of debate, as everybody does, through chopper memes. Chopper memes are the way that we solve problems. Like, we were down for 12 minutes. And, objectively, 12 minutes isn't very long. But in internet time, 12 minutes is like 2 years. And this led, of course, to internal debates at the company about how bad this sort of thing is, right? There are some people who believe strongly in stability, and they really want to make sure that performance and stability are up. They want to improve quality. On the other hand, there's, sales and management who want to build new features to sell. And so the question is, how do you resolve this sort of debate? What we need is a common language that allows us to describe the trade-offs between improving quality and improving features. We want something that can be understood by management and engineering, something that we can communicate to our clients and users so we can quantify how bad an experience was. We need to be able to answer questions like, how broken is too broken, so we can talk about how bad that incident was. And the converse of that, we want to be able to say good enough with enough confidence that we can say, yeah, our system's doing good enough. And of course, we all live in a world where we have lots of systems that are chirping their distress at us kind of nonstop. So it'd be really great if this was also an abstraction that would allow us to combat alert fatigue. The notion of service level objectives, or SLOs, is an abstraction that allows us to be able to express this idea. If we can talk about how good our system is quantitatively, then we can decide where we are sitting on that scale of good enoughness. Roughly speaking, the way that I'm going to summarize the idea of service level objectives is to say that your telemetry system produces or consumes events, and that those correspond to real-world use. These are our users' actual interests in what the system does and what data is being collected. Now, of course, the world is filled with events that our systems are producing, so we're only going to care about some of them, the eligible ones. And of them, we hope the vast majority of them are good. This is pretty great, because now we've defined this idea of a service level indicator. Given an event, is it eligible, and is it good? So, for example, this massive stream of data, some of them might refer to, say, things that are serving our web service. So some of them have an HTTP status code. And of them, if they were served under 500 milliseconds, we decide that's quick enough. And if it's served at 200, that says that we're serving the page successfully. So there we go. A good event is one that got a 200 and was served under 500 milliseconds. And this is great because now we have the ability to define the idea of quality. I'm going to have to do some math, and I want you all to brace yourselves. Quality is the percentage of good events divided by the total number of events. Now, of course, to be able to define that, we're going to have to pick a time range over which we're defining that. So an SLO, a service level objective, is a minimum quality ratio over some period of time. Cool thing about this now is that we've got a notion of an error budget. An error budget is whatever's left over. That is to say, if you are expecting, I don't know, 1 million events this week, and you promised yourself 99% of them are going to work, then you're allowed 10,000 things to go wrong. And if, only 200 of them have failed, you've actually got things to play with. And that's kind of cool. Because now that you've quantified what the notion of good enough was, and you've picked that bar which your users are comfortable with, you can do all sorts of great things with this leftover budget. You can start to deploy faster. You've got room to experiment. Go off and, set off your chaos monkey and go see what successfully tears down without being worried about failing your users' objectives. Or perhaps you might realize that, in fact, you weren't generous enough, that 99% you could do better. You could promise your users better than 99%. You could tighten your SLO. Having a leftover budget is great. Being out of error budget, conversely, tells you that it's time to improve quality and get yourself up to the standards that you've set. Now, going back to that incident I showed you, in fact, our company had worked out SLOs. Honeycomb is a telemetry company. We take in people's events, we process that for them, and we put them out afterwards in new computations and allow them to generate graphs and charts and interact with them. I'll show you more about that later, but to some extent that almost doesn't matter as much. What I really want to bring out is that users are sending us data. And it's really important to us that we keep that user data. So in fact, one of our SLOs is that we always store user data, and we interpreted that as 99.99% of events. For those doing the math at home, that does mean that 1 in 10,000 events can fall on the floor, and that would be unfortunate. But really, on a grand scale, we've decided that's an acceptable level, and so have our users. Now, we have a set of default dashboards that you load and a page that gets started. We'd really like that one to load in less than a second. But sometimes this page is running a little slow. It does depend on a whole bunch of components coming together, and our users seem to be fairly tolerant around that one. So we're placing that one at 1 in 1,000, 99.9%. And sitting behind all this is our grand data store. And many of the requests that gets are reasonable, and sometimes the requests are unreasonable, and sometimes traffic is bad, and sometimes Amazon S3 is quirky. And so we're going to see that queries often return in less than 10 seconds. So we have a 99% on that one. By the way, I know that I've been talking in terms of events. You can also sort of translate this in your head to time ranges, in which case we can say, for example, that 99% means that in the course of 1 month, we're allowed to have 7.5 hours of downtime. 99.9% would mean that we're allowed to have 45 minutes of failure total. And 99.99% would mean that we're down to 4.3 minutes. So we might ask ourselves, when we looked at that gap, what happened here? Was that 4.3 minutes 2 years in internet time, or was it just a passing blip? Well, that depends on which SLO we're talking about. Here's the bad news. This is user data throughput, which means that, in fact, we blew through 3 months' error budget in those 12 minutes. This was devastatingly bad. By the way, I'm going to say, when you're a telemetry company and you lose user data like this, that means that every single one of our users, for the next few weeks, as they looked at the graphs of their system, got to see that drop of us dropping the data. It was incredibly embarrassing. So what do you do in that situation? Well, like I said, we dropped customer data, and it was really embarrassing. We rolled back the bad change that had caused this to happen, and that's actually what took about 6 of the 10 minutes. We communicated the outage to our customers and apologized profusely. And we halted deploys. We stopped making changes to that until we had figured out what was going on and why. I'd actually like to walk you through some of the history of what we learned from that experiment too. The very first thing that happened was that a developer checked in code that didn't compile to our repository and attempted to push it into our continuous integration system. So we fired that developer and took care of the situation. Thank you all so much for your time. I'll talk now. We've heard today already, actually, about the importance of blameless deploys, about how human error is always linked to other source of error. Because let's be honest, that wouldn't have made a difference if our continuous integration system, our CI, had been working as it was supposed to. But it turns out that we were in the middle of experimenting with our CI system, and a bug had been checked into that recently, which unfortunately swallowed error status codes. Now, most of the time that doesn't matter and isn't noticeable because most of our developers were mostly checking in mostly code that mostly worked. But in this case, it didn't. Of course, that's not a big deal either. I mean, we wrote a 0-byte file and nothing was produced, which shouldn't be a big deal either, except that our deploy system very joyfully took this empty binary and spread it across every server we had, which still should be fine because, of course, our pulse tests, the health checks should have noticed that. We didn't have health checks at that time. That was bad. So our infrastructure engineering team simply stopped work on everything else that they were doing, and they focused on these points. Over the course of the next 2 weeks, we built ourselves a health check system with an automatic rollback. We made sure that our deploy system could not possibly deploy empty binaries, and we fixed our CI system so that it actually produced errors when a user checked in erroneous code. The notion of having service-level objectives allowed us to characterize what went wrong, how badly it went wrong, and allowed us to prioritize repair, to know that this was a big enough issue that it was actually worth repairing. Today, what I want to do, having introduced this idea of SLOs, is talk a little more broadly about our process of building an SLO feature in Honeycomb. I'm going to talk a little bit about how we used it internally and how we figured out what to do. I'm going to talk through some of the challenges and pieces of user feedback that we got around it. And I'm going to walk you through one other, also embarrassing incident that perhaps can help color some stories about the cultural change that happens around these SLOs. Now, I'd love to say that you don't actually have to listen to this talk because you could just pick up these books, which Google has available free on their website, and they each have a chapter on SLOs, and they're fantastically well written, and they're great introductions, and we tried that, and it wasn't enough. Because it turns out there's a lot of subtleties. I'm going to talk a little bit about design thinking and sort of how I approach this kind of problem. I'm going to talk a little bit about some of the experiences of creating SLOs and expressing them and how you view them. I'm going to switch over to talking about how you respond to SLOs, and then, like I said, I'll wrap up with learning from some of the experiences. Now, my background and training is in human-computer interaction and data visualization. I profoundly care about how people visualize, analyze, and interact with data. And I've been trained, and I love spending hours looking over people's shoulders, seeing them play with data sets, and figuring out sort of both what we do well in those systems and what parts we could improve. In the process of doing this, I was delighted to not only have access to, to not only be able to go out and interview and study people, but we had internal users, we had experts in the creation of SLOs, we had internal teams, and we were able to pull things from our customers and get a small group of early responders to play with this system and be able to give us feedback. Which meant that this is going to be really a conversation about design, about understanding users' tasks and understanding users' questions, and talking about some of the approaches that we use to these. I'd like to start off, as I said, with talking about the idea of just displaying an SLO. I've given you this nice overview of here's a failure, and we did the math by hand to sort of compute how many minutes of failure we had. Our real goal here, though, is to not only see that we are burning through our error budget, we want to see where the burn down was happening. We want to explain why it happened, and if at all possible, we want to give some cues that will allow remediation to happen as quickly as possible. Now, for those of you who have looked at SLOs in either competitor products or in the Google SRE book or various other sources, you're going to notice that there's actually two different sets of conversations around SLOs. I give you the definition that's event-based, just percentage of events that had a duration, say, less than 500 milliseconds. There's a whole second school of thought, and you're going to see it in some other products, talking about how many 5-minute periods had a P95 of duration less than 500 milliseconds. If you're working with a system that is actually based around the idea of collecting metric data, this sort of thing actually works much better because you've got that P95 floating around. Honeycomb is based on individual events. We really care about keeping those individual events. And so for us, this left definition works better. It's a vendor talk. I'm biased. But I know how to do this math in my head, and I still haven't been able to get my head around this one statistically. For the rest of this conversation, though, I am going to be talking about the event-based genre of SLOs. So our first question was, how we express SLOs. I have a little bit of a background as a designer, and my first take was that we should make this, super straightforward for our users. We should build them a little wizard and allow them to fill out a little form that will allow them to express, what to do. And I showed this to our engineering team, and our engineering team said, "Really?" And they showed it to some first users, and they sort of blinked at me and said, "You're kind of overthinking this." And they pointed out that any of the people who we were targeting SLOs at was actually pretty good at using our internal expression language and was pretty good at expressing questions. So, for example, if you really cared about, events called name is run trigger detailed, and you want to make sure that good events are those that an error does not exist, you could just write this as an if statement. And so this is our own internal mini language. And this was enough to get us, sort of through that first beta and get something into users' hands. And presto, 5 screens worth of development and and lots of prototype kind of went away, which was great. Now, as users have continued using this, they're getting more and more complicated. This is actually one of our current active SLOs that we use internally at Honeycomb, and it says that events that aren't from internal Honeycomb users, because we have weird usage patterns, and that aren't from us sudoing into someone else's data, and that haven't spitted out this message about this data set has been deleted, are the ones that we care about. And then if they've got a status code of 403, and it's long, it's complex, and we're beginning to rethink this decision about building the wizards, precisely because we're finding that the conversations that people are putting in is getting longer and longer. And that's great. This is the user feedback that we actually need and want. And so we've been monitoring the SLOs that our users are creating. Once you've written this expression, though, it's actually pretty straightforward. You need to specify a time period that's going to act over in days and a target percentage, and you fill out those 2 fields and give yourself some cues about why you created this thing, and you're pretty much set. What we're able to do for that is then show you where the data was where your quantity of data was burned down over the last few days. So in this case, for example, we have a data set that 30 days ago started at 100%. It's been gradually burning its way down. It's now a month later, and we're down to 57.5%. By the way, again, the value of user feedback. When we first created this, we just had a chart that ended right there. And someone said, the only part about this chart they really care about is the number at the end. We said, well, you can make that pixel really big. And they said, or you could just put the number on. And we said, oh, right, we could. And that was one of those duh moments that made everything better. We also realized that tracking how well you were doing over the last period is really useful. So this, for example, is the history of compliance, which says, we really wanted this SLO to be 4 nines. Holy crap, we're actually at 4.5 nines. We've been wiggling around for a bit. We're even higher than that. We're getting dangerously close to 99.996%. Isn't this exciting? Let's look at some more, we've actually got these 2 charts next to each other. It's kind of nice to be able to compare them side by side. Here's a more interesting example. The SOI and homepage no error SLO was doing pretty well and burning down at a perfectly reasonable rate till, February 13th or so, when it plummeted, went across, plummeted again, and has kept plummeting and has now stayed stable at negative 176%. You can also see, by the way, that we have not made our, SLO target on this for quite a long time. For a while, it was looking like we were at least in the general vicinity of 99.2, and recently we're down to below 99%. This one's embarrassing. Let's talk about how we diagnose this sort of thing, how we understand and learn from this, right? I mean, this drop is nice, but what caused the drop? What happened there? So the next thing that we've added is this visual presentation that shows you a heat map of precisely where those errors were. Now, you remember I've been talking about the idea of SLOs as events. So we're actually able to draw individual events that have failed on this chart. Now, this particular SLO is based on both latency and errors, and so you can see that everything above a certain threshold is just being painted yellow. Those are errors. They're too slow, right? That's what failing means. But then we can also see that there's a whole smattering down here of fast failures, of ones that have, of things that have returned an error message. And so just seeing this chart is not a bad start to understand, like, are we failing because of latency, or are we failing because of error message? We can take another look, for example, at that minus 176. We can go drop through time to 14 days ago to get ourselves right back here. And we can see that this was a huge batch of events that all happened at once. That's kind of cool. This is not apparently a systemic problem. It's not our system failing. It's that for some reason, there was a bunch of things that generated error messages very quickly all at once. So now we'd like to, of course, understand why they went wrong. Going back to our notion of events again, this idea that we've got individual discrete events that we can look at and say these are good events or bad events means that we can do all sorts of wonderful things. So for example, each of these events has many, many dimensions on it. Ranging from, like, the request URL to, user ID and data set IDs and various variables that were associated with, and the response status that it spit back, and what error message it was producing. This is pretty great. For each of these so what we've now done is for each dimension in this data set, we've drawn a little histogram of the events that succeed and the events that fail. Succeed in blue, failure in yellow. And there's some things that are completely unsurprising, right? We said that we're monitoring for errors, and hey, what do you know? The errors are 400s and 500s, and the 200s are successes. That's what we'd expect. Therefore, there's error messages defined for, the yellow bars are all there for the error messages because, yes, that's what an error means. But then there's some other fun things that shows up. Like, for example, all of those errors are apparently due to 2 specific user email addresses. And they're due to 2 specific user teams. So suddenly, this isn't a story about the whole system being highly unreliable. It's a story about 2 users having a very bad experience. Now, I'm not trying to be cavalier. I don't want 2 users to have a bad experience. But this feels like a sort of different sort of response that we might want. And in fact, when we look at the error message specifically to see what happened, it was could not find team. OK, that's really interesting. So what this means, we've got users who logged in and they got an error message, and the error messages could not find team. What this actually means is that we've somehow built into our code a mechanism that allows you to log in even after your data has been removed, or after you've probably stopped being a customer. That's kind of cool. We've now got a customer service issue to find out why these people are still logging in and what they're hoping to find. And we've got a technical response, right? Our dev team should go out and go fix that bug. If your data's been deleted, you shouldn't be logging into our system anymore. So this is touching on that goal of seeing where the burn down is happening, explaining why it's happening, and remediating. So we rolled this out as a beta, and we were very proud of ourselves because, look, we had these cool charts and we had these graphs, and we got user response like, wow, this is great. It's allowing us to figure out what's contributing the most to missing our SOIs. And we said, yes, we are succeeding. To the millisecond, we knew what our percentage of success was versus failure, and we said, yes, we are showing them what we need to. And someone said, this confirms a fix for a performance issue. And we said, we are getting there. And then someone said, we don't have anything to draw us in. And it would be great to have a sense of where the budget's going. And we realized that we had this beautiful page, and no one had any reason to look at it. I mean, they look at it the first time they created it, and at some point someone goes, how's that SOO doing? And says, oh yeah, how is that SOO doing? So we realized we really needed to talk about burn down alerts. We needed an ability to express why something was going wrong. So we wanted to be able to, and so going back again to the user goal, we want to be able to figure out how long it will be before I run out of budget. The reason we want to do that is because we were really interested in human digestible units. That is to say, if you're going to run out of budget in, say, 24 hours, then you should probably, get a full night's sleep, wake up in the morning, and go check it out then. If you're going to run out in 4 hours, you should probably wake up some other support folks, get the team together, and figure out what's going wrong and why it's going so badly that you're going to burn through your budget. And in fact, we've specifically built in a system that allows you to support this with a pager call, and this will happily post to Slack or something. So you can pick your level of urgency and your type of response. Our prediction mechanism is as simple as we look at the wiggly line in the past, You pick a period behind it, and you extrapolate forward to figure out about when we're going to exhaust, and if it's above your alarm system, then you go with it, and if it's below it, you don't. So that was pretty straightforward, and we were very proud of ourselves for having, built our first burn alerts. The mechanism is actually quite simple. If you've got this 30-day data set, you run a 30-day query, and do so at about a 5-minute resolution so that you can make sure that you're getting all the latest data, and you probably do this every minute. Now, you know how they say premature optimization is the root of all evil? Sometimes post-mature optimization is a little bit of a problem too, because we managed to burn through $10,000 of Amazon. There's the first 5.5K that day, and here's the next 4.5K, before someone said, ooh, a 30-day query running at 5-minute resolution over the last month, repeated for every SLO that we have running, repeated every minute, begins to burn through a lot of resources. Fortunately, as computer scientists, we understand the right answer to this one. It's straightforward. You just have to implement a cache. There's absolutely no problem with that. All we have to do is, cache our results, except not incomplete results, and not, This was actually turned out to be more of a challenge than we thought. Our back-end servers had never been designed for building reliable, high-speed caches. We had always been okay with the idea that some percentage of queries might miss by 5 or 6%, and that's okay because users press refresh, they run queries. Almost all our results were pretty transient. And now we're moving to a space where they're not only important, but they're meant to be actionable, and they needed to be precise. And so we actually had to re-engineer some of our query engine to make absolutely sure that the data that we were producing was high enough quality to make sure that the front end was able to trust it and cache it for an entire month at a time. Once we resolved that, we suddenly started having alerts flapping on us. And this turned out to be the system would predict, hey, it's going to fail in 3 hours and 55 minutes, throw an alert. And then a good event would show up, or 2 good events would show up and say, oh, well, we're fine, we're out of the woods. It's 4 minutes and 1 minute. It's 4 hours and 1 minute. And then a bad event would show up and say, wait, make that 3:55 again. And it would keep flipping back and forth and back and forth. And the alerts would sit there flapping. And we're like, wait, the whole point of SLOs was to get rid of flappy alerts. What terrible, what have we done wrong? Turns out that when we stared at the data a little bit, we looked at the examples of alerts that were flapping, and we threw on a 10% buffer and all went away. Because by and large, a 4-hour alert was almost always right-ish, and so if it didn't reset until 4 hours and 20 minutes, you were fine. The newest feature that we're now working on is the idea of recovering from bankruptcy. You remember I showed you that example of the events that were running at a minus 169%. In theory, no alert should go off, and no alert should continue to go off anytime because we've already burned that budget. And we're just going to have to sit there and, come back to that page, I don't know, every couple days and hit the refresh and watch that negative 169 crawl its way back up as we regain error budget. So we're building in a bankruptcy mechanism that will allow us to get new alerts even after you fix the problem. Interestingly, as we were talking about this, we went out and chatted with some of our users who were active users, and it turns out that their workaround was to delete the SLO and then recreate it, which blew away the cache, which caused them to, start getting new data in, which was fine, but kind of embarrassing from a design point of view. I don't want our users, having to give each other that sort of horrible advice. I'd like to actually, provide a system that works for them. In the process of building these out, we've actually learned a lot about the experience of working with and building SLOs. The first one was that volume turns out to be really important. No matter what level of nines you have, it turns out that we really need to see, it seems, if you're not seeing, your SLO level needs to tolerate in the dozens of bad events a day. If you are either getting such sparse data or such slow data, or your level is so very high that 2 or 3 bad events throw you, then what you start seeing is, again, the flappiness, right? 1 or 2 bad events come in, and all your alarms go off. And then, it takes a while to recover from that. one or two bad events is, if you're really at the one or two bad events is going to sink my company level, you probably are pretty happy with the classic alarms, classic triggers sort of model of like, a thing went wrong at least once. And everyone's pretty okay, and most systems are pretty good with that. SLOs are a really good way of expressing the idea that your system is beginning to degenerate, and we'd like to be able to express that. So again, you need to be able to tolerate at least dozens of bad events a day. More interestingly to me, is we started having to distinguish between our fault and our user's fault in our error messages. Our system, if you sent us bad data, would very happily return a 500. You sent us bad data, that's a 500, can't be processed. Also, if our backend server had failed and we couldn't process it, we'd also send you back a 500. And from a user point of view, that was pretty much right. Our 500s came with a textual description of what had gone wrong. And either way, we wanted you, as our client, to cache that event or to somehow absorb it to figure out what was going wrong and perhaps resend it to us later. But under SLO world, that became a really important distinction. And in fact, we had a day of like all of our SLO alarms going off simultaneously, and it turned out that was because like one user had tried to send us terabytes of badly formatted data that we didn't know what to do with, and so we kept returning 500s for them. So a number of our systems have now started adding our fault and their fault. I'm actually giving you snippets of like the actual Honeycomb source where we annotate it with the our fault and their fault. Another interesting learning to me has been this idea that SLOs are also a way of supporting your customers and finding out what their experience is like. Again, I gave you that example earlier of looking at the data set where we saw that it was one particular user having a bad experience. The number of our SLO challenges that have fallen around one particular user or one particular instance has probably 2/3 to 3/4 of the incidents that we've seen have been based on that kind of challenge. And so the ability to flag, hey, this is the user who's having a bad experience, you can reach out to them, has meant that we've now got the Honeycomb customer success team also looking at SLOs and sometimes writing their own SLOs to go know which users to reach out to and where challenges have been coming up. The last important realization that I think has come up is that blackouts are super easy. That first incident that I showed you, we didn't need SLOs to discover it. Literally every alarm bell at Honeycomb was going off. We were losing customer data. That's alarmed, through the gills. Every system that could possibly notice that customer data was supposed to be coming in was failing. Blackouts are easy. What's really interesting about SLOs is the fact that they notice gradual degradation. They notice slight failures and partial issues. A couple months ago at 1:29 a.m., our new SLO system barely approved. In fact, we had them in a temporary Slack channel because we didn't really trust them yet, went off and said that our ALB response codes are not matching what our internal system does. Now, this really just shouldn't happen at all. So we had that one set at 4.5 nines. What is that? 1 in 20,000 events. It really should be super rare. And it alerted. And our on-call person glanced at it and said, oh, that's probably just a blip. I don't know what's going on. Later on, we'd analyze it and find out that we actually lost 1.5% of events for about 20 minutes, which is embarrassing, not necessarily devastating, but embarrassing. And here it is afterwards. You can kind of see, and to give away a little bit of the punchline, the distinct number of host names, the number of computers that were running, plummets. And then it climbs back up and everything's fine. And it blipped again at 4:21 a.m. Now, one of our techs happened to know some folks that are on the Amazon on-call cycle, and they reached out to each other and found out that Amazon ALB had been having some problems, and so this is probably just an AWS problem. The reason why we're seeing those falling off is maybe the Amazon ALB system is dropping some of our servers. It's probably not our problem. And 6:25 a.m., we're pretty sure it's Amazon, and now our team's getting really annoyed that Amazon's screwing us over. Don't they know we're trying to run a reliable service? It wasn't until 9:55 a.m. that a more awake on-call tech took a look and said, When ALB seems to be hiding us, our system uptime's dropping to 0. Something's out of memory. And we'd actually stopped alerting on out of memory because, again, we have hundreds of spot instances which were temporarily running, and they'd go up and they'd go down all the time. And it wasn't considered a huge deal because, again, sometimes systems run out of memory. All of them running out of memory simultaneously and then dropping to the floor, that's not so good. And this was happening on a 4-ish hour cycle as they'd all gradually, slowly out of memory and fail, and all slowly, gradually come out of memory and fail, and all slow. At which point we finally figured out what was going on. We'd dropped in a change in our code that was burning through, that was generating, infinite memory use, filled up, and within a few minutes of figuring out that that's what we were doing, we were able to stop the next cycle from happening, and everything was fine. In fact, hey, global memory and use chart, if you go look at it, here's where the fix goes in, and you see like the machine's propagating, and now they're not using as much memory, and here they are, doing just fine, using almost no memory as we expect them to, and everyone was happy. By the way, we can, of course, view this in our SLO view, and you can see up until this incident, things were going great, and then they weren't so, and we get these nice big, broad yellow lines where the systems were failing and all the events turning bad. So this slide should be familiar. How do we fix it? We stopped writing new features. We prioritized stability. We mitigated risks. We apologized to our customers. Oh, and one last thing. We promoted our SLO burn alerts. Because this was a failure that the SLO system had caught super early, was super aware of, and that the dev team, who didn't quite trust SLOs yet, was saying, well, we're not seeing our other alerts go off. This is probably okay. And to me, that says that there's also this piece of cultural change. It's hard to move from, I know why this alert went off. It went off because we have seen 15 errors, on Wednesday, to change to this idea of, are we at the level of reliability that we expect to be? Ironically, having this really clear incident could helped a lot because people were able to go back and say, wow, if we'd really trusted SLO, we probably wouldn't have said blip. We would have said, this isn't the story that we want to be telling. The positive effect that's coming out of this SLO experience, by the way, has been that we've been able to reduce alarm fatigue a lot. A couple of months ago, we were more often in a situation where where we had alarms on things like running out of memory, systems crashing. We're moving more towards a world of user-facing and user-affecting SLOs. The system has failed in a way that users can potentially experience, that's affecting the downstream clients, and we are going to we're moving to actionable alarms that say, this is a thing that we're seeing, and this is how we're going to resolve it. I'm going to wrap up by saying that, as I said earlier, SLOs gave us a tool to characterize what went wrong, how badly it went wrong, and how we wanted to go ahead prioritizing repair. Now that you've got these tools, I'm just trying to spread the gospel. I want you to do it too. It doesn't have to be with our tool. There's a lot of opportunities out there. But the ability to move towards alarms that are specific, that are actionable, that are effective, that speak to the user challenges, not to your understanding of what your computer's architecture is, will hopefully allow you to avoid our mistakes. That said, this is a vendor talk, so I'm going to say you should go upstairs to the 5th floor. We've got a booth, we've got demos, come kick the tires, come check things out, ask me questions. If you just want a copy of the slides, they're honey.co/Daniel or at the QR code. Thank you all so much for your time and attention.